Hi guys, just going to talk you through task 3 for networking. A lot of it you can just copy and paste from task 1. You do need to repeat it because it's relevant, and then we'll just add to it. Basically, it's about protocols and standards, as we discussed in the first section. These are just ways to set up sort of default ways for the computers or hardware on networks to communicate to each other. It's like learning a language. You know, people from England all speak English, they can communicate to each other. But then if you throw someone in from a different country, it's a little bit harder or impossible to understand them in places as well, unless you learn the language. And all the hardware needs to know what language it's speaking. So there's many different agreed terms and ways you can do it. TCP/IP, massively common one to communicate on networks. The main way probably. And a lot of these that we're going to discuss here at the bottom, DNS, DHCP, HTTP, they use TCP/IP as the actual language they communicate in to perform their functions, which are different and more specific. AppleTalk, as I mentioned in the lesson, is redundant now. It's not really used. Apple used TCP/IP as well, but that was Apple's way of doing it. And it's how the computers sort of interact to start off with mostly. Yeah, they explain who they are, where they are. Maybe the best route to communicate to them through, and they'll explain what they want to do. Do you want to transfer a file, or do you want to stream data, or whatever they're doing? So I'm going to focus on the ones at the bottom here. All of these can pretty much be shown with the diagram there at the bottom. It's a very basic internet diagram. You'll always find, I don't think I've used it yet, but the internet is always shown on diagrams using a cloud, and if you go to university and things like that, they'll expect you to document it that way as well, so it's something you should get used to. So, we'll start with DNS. DNS is Dynamic Naming Service, or Dynamic Naming Server, and basically it's a way for all the computers to know where they are. It's kind of like an address book, really. Everything on the internet is all registered with an IP address. Yeah, a specific number. You get those on your network as well. You might have a separate one for the internal IP address inside your home network. Then you'll have your internet IP address, which obviously there's a lot more computers on the internet, so it has to be organised in some way, shape or form. DNS is mainly used when you're converting into connecting to sort of web addresses. That's what it was invented for. So when you type www.google.co.uk, that has to be converted to the IP address, and then the computers then have to be pointed in the right direction on how to retrieve the data from google.co.uk. Otherwise, they wouldn't. The computers don't understand the physical words that we use. They just have a number and a binary number to them. We still see it as a normal number if we write down an IP address. So, for example, if you typed in google.com or co.uk, you want that to go out of your router or to your router, then out to the internet, and hopefully the hosting provider would be Google, and somehow you'd get there. But how do we know it's there? Well, what happens is every computer is registered to a DNS server somewhere on your laptop or computer. It comes built into the devices. It'll have a DNS server set up. You can actually change your DNS server if you really want to. Most people just stick with the default one. So the first thing that happens, you've typed google.co.uk, that message goes straight out to our DNS provider. Yeah, like I say, it could be your ISP or your, I don't know, TalkTalk Broadband or whoever you're with for your internet, and it sends back the message. Right, it's at 192.168.0.5. That's an example of an IP address. At which point, then the computer then uses the router and it'll go find that data, hopefully. And that's it, really. So it's just for converting. So this computer here, there'll be many of these on the internet. They're all connected in some way, shape, or form. When you buy a domain name, if I was to buy leepayton.com, and I would register it where I wanted that to go. So I would tell it that my IP address is where I would like that. So that if another computer connected to the DNS server through the internet, they could retrieve the data from my computer and load the website on my computer. That's it. We'll have a look at DHCP. Different sort of utility, different service than DNS, but can be shown on the same simple diagram, really. DHCP is, like DNS, is about converting sort of worded addresses into the number so that it can be physically found on the internet. DHCP is actually in charge of setting IP addresses for computers, and you can do it in two different ways. You get a dynamic or a static way of setting your IP address. A dynamic way is automatically set by the router or by by the company, yeah, and it'll be automatically generated. You tend to find that they change, maybe not every time you log on, but if you restart your router, or it might change weekly or monthly, and there is benefits to that, but we don't have to discuss those here. The other one is static, and that means it never changes. You can actually pay your ISP extra for that, and you might want to do that if you were hosting a computer and you didn't want your IP address to change, because otherwise you'd have a problem, because the DNS server would know a certain IP address for leepayton.com, for example, and if that IP address was to change, then it would point you in the wrong direction. It wouldn't actually go and find the data, or find my website that I wanted it to. So when you're hosting a website, you tend to use static IP addresses. In fact, you almost always use static IP addresses, and that has to be configured on the DHCP server. So again, a bit like DNS, you can have internal sort of DHCP for your home network. You might have these on your router at home. This is why you don't really have to set an IP address. You just you connect your device, whether it's your phone or your laptop or your computer, and you are just designated an IP address. Yeah, and that probably, like I say, it can change. It will change the more devices you add on. The router will choose those, and as and when it sees and it needs to, it'll set them up for you. It's the easiest configuration. It might not be the most secure or anything like that, but for the majority of users, it's absolutely fine. The other one is when you connect to the actual internet. So when your router connects to the internet, it needs to get its own IP address. It'll request that from Sky Broadband or BT Broadband, whoever you're with, and they'll set it. Okay, like I said, you can pay extra. It depends on the company how much it costs for a static IP address, and it's usually businesses and people hosting services like websites that would do that. So just to clarify, the difference is DNS is all about a computer that knows the address book and knows where Google's data should be stored on the internet and points people in the right direction. DHCP is actually the service that selects the IP address and either generates it for them or ensures that they get the static IP address that's been chosen for them. So lastly, I'm going to cover the last three as a whole, really, because they're three very similar types of service. They're all about hosting a certain type of data online. Your HTTP, Hypertext Transfer Protocol, is the way that website data is transferred. Okay, your FTP is file transfers. So if you're storing things on Dropbox, for example, that use an FTP to transfer the whole file and ensure it gets to where it should be and ensures that it's all intact and you get the whole thing. And SMTP is Simple Mail Transfer Protocol, and that's what not every, but the majority of outgoing emails are sent in. So whenever you send an email, it goes in the form of that. And there are just certain ways of packaging that information and sending it across the internet, and they'll include things like data checking and things to make sure it gets where it should go. Simply, after DNS and DHCP have been chosen, when you connect your computer to the internet, you will type in HTTP:// or you don't need to do it because the computers are clever enough to recognise it, but you can type it in. You've all seen it before when you've typed a web address in. It goes to the DNS server, tells it where it is, then your computer will then connect to the host. Let's say it's a website, let's say it's Google. It'll recognise that Google's an actual, it's a website, so it'll know HTTP is the most appropriate way of doing it, and then your computer will communicate in HTTP, and the website files will be transferred back to you. It's exactly the same for file transfer. Yeah, it's just a different way of sending it, because files will require different rules to transfer the whole file and make sure it's not corrupt when it gets there, so there'll be extra data checking in that. And your email, that'll depend on the configuration. If you're using encryption and things like that, then that might have to run through extra protocols, and that'll all be configured on the SMTP server. So those three are all types of server and types of ways of transferring for a different service. Just to clarify again, websites, which you should all recognise, files for file transfer protocol, and simple mail, which is email. Just to make it really, really clear then, guys, for your explanations for task 3, I just need an explanation of what each of these things does. And just to clarify again, DNS, dynamic naming service, okay, picking or converting a name to an IP address so that the right website can be found using the right words and IP address conversions online. DHCP is the act of actually configuring who gets what IP address, whether that's dynamic or static. HTTP, FTP and SMTP are all types of protocol for transferring different types of data, website data, file data, email data.